Point three, elastic and inelastic collisions. Okay, so what is the elastic collision? When two balls move toward each other, each has some velocities, and after collision, they perfectly bounce back. So the elastic collision, the total kinetic energy after the collision equal the total energy before the collision. Also, the momentum is conserved as well. So EK prime is equal to EK and P prime is equal to P. When you have a prime, it means after collision. The total energy after collision is the same as energy before collision. The total momentum after collision is the same as total momentum before collision. So when like that, when you have a bigger ball, let's say there is friction, let's say tennis ball has some friction, when they bounce back, some energy will be lost. So we have inelastic collision. In elastic collision, the kinetic energy is not constant. Means the total energy after collision and before collision is not the same, not equal. But the momentum still is constant. Before collision momentum, after collision, before collision, equal. And when we have perfect inelastic, and these two soft balls come together and they stick together and they move on with some velocity. This is inelastic and they stick to completely inelastic. The energy is not conserved. The momentum is conserved. The energy before collision is much more greater than energy after collision. So we do an example to see that better. So for conservation of the momentum, we want to know that mv1 plus mv2, this is the total momentum of the object 1 and object 2 before collision is equal to momentum of the object 1 and momentum of the object 2 after collision. So it should be equal, conservation of momentum as constant energy. The energy before collision is equal to the energy of the after collision for these two balls or objects colliding. Okay, look at this question. A billiard ball with mass m and initial velocity v1 undergo a head-on elastic collision with another billiard ball. So the mass are the same. Initially stationary with the same mass m. So here it said the second ball is a stationary. So v2 is equal to 0. What is the final speed of the two balls? So we can establish the conservation of the energy and momentum. Knowing the masses are the same, so I can divide each term by m, so m will go away. The same thing for this one, we can divide each term by m. Also, I can multiply that every term by 2, so 1 over 2m from each term is canceling, and we have that. And m here from each term is canceling, so we have this. v2 is 0, right? So v2, if you put that 0 here, and you put that 0 here, because the before collision v2 was a stationary, and we have these two equations. So from the second equation, we rearrange for v prime 1. So it means v prime to the other side become negative. So v prime 1 is equal to v1 minus v prime 1. And then instead of the v prime 1 in the first equation, we put v1 minus v prime 2, as they did it here. v1 minus v prime 2 power 2. We expand that. So the number power 2 minus the first multiplied by the second, twice of the first multiplied by second, plus the last number, power 2. So you expand that. Okay, we have a v prime v1, 2, so we can cancel v1, 2 from both sides. See, v2 prime 2 plus v prime 2, so it's 2 of them, so it's become 2v prime 2 power 2, and here negative 2v1 v prime 2, so we have that here. We can factor out v2 prime and the negative, so from that the v1 is remaining, and from that is v prime 2 is remaining. So there is two possibilities. Two things multiply each other is 0, means the first one is 0 or the second one is 0. If the first one is 0, it's impossible because after collision is not appropriate solution. The second ball is stationary after the collision. So V1 minus V prime 2 is more reasonable. If you equal that to 0, you get V prime 2 is equal to V1. This more makes sense. So we got for V prime 2 equal to V1. Now, if you had this V1, we have this equation before, V1 is V prime 1 plus V prime 2. Since we proved that V prime 2 is V1, this V prime 2 is equal to V1. So we use that one instead of the V prime 2, we put V1. And as you see here, the V1 and V1 cancel. So V prime 1 is equal to 0. So what is happening? So this is coming, this is a stationary. When the V1 come and collide with that, V2 will move with the speed equal to V1, and V1 kind of stopping here. Means all of the kinetic energy is transferring to the second one. Means which makes sense. Let's just do another example. A child rolls a super ball of mass. The mass of the ball is given. At the table, the speed of that is given, as you see in this picture, the speed of the first ball and the mass of that is given. And it's had a collision with a smaller stationary ball with the mass 2.10 power negative 2 kilogram. The collision is elastic. Determine the velocity of each ball after collision. If this is elastic, we have conservation of the energy and momentum. You write it down. Since the masses are not the same, so we cannot cancel it. Just the 1/2 here we can cancel, right? So we have these two. We can, so this is equal here. So V2 is 0. V2 is 0 means this term and this term is gone. Now that's why you don't see that there. So this is guys, this is equality here. Make sure that we don't have the V2 and V2 at the left side because it is 0. Now from the second equation, we can rearrange for V prime 1. So move M2 V prime 2 to the other side, become negative, and you divide each term by M1. So if you do that, this M1 cancel, this become cancel, this become M2 over M1. This is what we have. Now, since we have these numbers, we can just try to put that on. So we have V1, which is 2.3. We have mass 1, mass 2, we divide, and here is V prime 2. So we have a V prime 1 in terms of V prime 2. Then we can use this kinetic conservation of the kinetic energy. So instead of the V prime 1, I can put that expression, which is 2.3 minus 0.8 V prime 2. All right. Okay, so first what they did, they just they subbed the number. So M1, they put it there, V1, they put it, V prime 1. We don't have what we put the M1 and M2 here and V prime 2. So as you see, we can divide each term by 2.5 10 power negative 2. I think they did it in the next step. In the next step, we can cancel 10 power negative 2, right? So we can divide each term by that number. So this is what we have. Then you multiply 2.5 by 2.3. This is what we have here. And these are generally. Now, before we got, and instead of the V prime 1, see V prime 1 is 2.3 minus 0.8 V prime 2. And instead of V prime 1 here, we sub that expression. The reason is that we do that because we want to have just one variable in our equations, right? So we expand it. So the first one power 2 minus the twice of the first one multiplied by the second one. the second one power 2. And you multiply this number in, you gather the like terms. So the v prime 2 here is there. So you just, these are the like terms, v2 prime power 2, v prime 2 power 0. This 1.6 plus 2 is 3.6, v prime 2 power 2. Then you can factor out, so 13.2 and 13.2 will cancel from both sides. You can factor v prime 2 here. Now this expression, these two expressions multiply each other is 0, means the first bracket is 0 or the v prime 2 is 0. So if the v prime 2 is 0, it not makes sense, but we equal this expression equal to 0. So for v prime 2 is 2.6. And we had this one for v prime 1 in terms of v prime 2 before we used it to find the v prime 1. Okay, so that would be it. So to practice, you can do question number 10 and 11, page 251.